Welcome to my demonstration of the instrumentation and measurement project, where I have built a inertial measurement unit with a 6-axis gyroscope and accelerometer using a MPU 6050 chip, a SD card interface, and that's all run off the Arduino Nano that I have plugged in there, providing me with yaw pitch roll of the sensor as well as the acceleration in XYZ and the time for each of those readings. So I'll get further into the demonstration now. The system itself uses a Arduino Nano microcontroller to run the sensor, which is a MPU 6050 up here, a 6-axis gyroscope and accelerometer, so 3 axes for each of those, providing yaw pitch roll as well as acceleration in X, Y, and Z axes. And finally, the SD card interface over here that uses an standard SD card and is able to log the data that is output by the sensor after it is processed by the microcontroller. And then it can be placed into any computer and read straight from there. The Arduino is programmed using the Arduino software that you can run on any computer. And using this, I'm able to also interface directly with the Arduino, allowing me to demonstrate the program quite nicely. Using tools and serial monitor, it'll pull up the Arduino Nano, and I have the program holding here for the purpose of this demonstration because these messages will come up telling me that I've initialized the IMU and SD devices. If any of these fail, then there will be an error message coming up instead of successful and initializing. Once I put in any character, it will begin the program measuring. Each measurement has a time value attached to it. This helps when you are analyzing the log data, and this gives your roll pitch and acceleration in XYZ. Now, when I roll the device, you'll see that the roll value will change and go negative through positive. Pitch works just the same, all the way up through positive, and yours gimbal locked, which means it will not be able to adjust with normal turning. So once it's started, it locks that as 0. Acceleration will also work. Acceleration in the Y direction, the X direction, and Z. The Z direction will normally read as close to 1 as possible. That is because it is reading the usual value of G. All the values for acceleration are in G, and the yaw roll pitch are in degrees. I've let the program run on longer here, and to finish it up, all you need to do is either close the window, or how it would normally be used is when you remove power from the circuit, the readings will cease, obviously, because the circuit's now unpowered. At this point, the data will dump directly to the SD card, and it'll be ready to be read by a computer and properly interpreted. Okay, so now I've placed the SD card in another computer so I can read the data that comes off it, and all the data is stored straight into a text file. So it's just a normal notepad, and that can be manipulated however you like. So with all the data, you can see the timestamps down the side here, the acceleration, XYZ, and the yaw roll pitch. I'll scroll down and we'll see where I begin to play with the sensor a bit more, and that should show the normal results. Okay, this is the data from one quick pitch test that I did, and I've added the roll on there just for a bit of reference. You can see the pitch quickly climbs and then drops as it switches the other way while I'm manipulating the instrument. I've also done, with the same data, an acceleration test, and here you can see the XYZ acceleration for a few seconds that I picked out there to graph, and you can see where while I'm shaking the device and moving it around, you can see all the accelerations in the X, Y, and Z direction as they continue through time. This is how the data can be graphed and analyzed after it's been gathered and opened up in Excel.